Okay. So here it is the technique that since for instance the Hamming code or C cyclic 7,4 has a generator polynomial with just 3 roots and is not able to guarantee the correction of any error pattern of size t equals to 2, it would be possible to add the missing root alpha cube by forming a generator polynomial as the multiplication of g1x and g2x. Very important. What it is telling that since for instance the Hamming code 7,4 has, or you can say the cyclic code 7,4 has a generator polynomial with just 3 roots. Only 3 roots are there. But this is not possible to correct the error pattern of size 2. So it would be possible to add. So we need another root. So it would be possible to add that another root from the another possible polynomials, or you can say that another possible factor polynomial, which is, that means we are dealing with g1x, right? Our generator polynomial is g1x, and we have the roots of alpha, alpha square and alpha to the power 4, but the received code in reality, there we need 4 equation, but we have only three roots. So we need another root to make another equation. Okay, so all total we need 4 equation, but we have only 3 equation with 3 root alpha, alpha square and alpha to the power 4. So then we can consider the root of another possible polynomial of g2x. What is the g2x? g2x equals to alpha, sorry, x cube x square plus 1, right? That means this we are dealing with this, but we are facing problem because we have only 3 roots. We need another roots. So that's why we can consider the another possible polynomial equation and its roots, like alpha cube, alpha to the power 6 and alpha to the power 5. So that's why we are multiplying g1x, that means this is g1x and this is g2x we have considered in book. Okay, so here it is written that, okay, so it would be possible to add the missing root alpha cube by forming a generator polynomial as a multiplication of g1x and g2x. However, it would be more appropriate to take the lowest common multiple or LCM of these 2 polynomials. That means we have to take the LCM of the roots of g1x and g2x. So then we will have all the possible roots. Okay, when we are doing LCM of the possible polynomials, that means from this table, when we are considering this is g1x, this is g2x, when we are considering the roots of all possible polynomials of gf8, okay, so and making the LCM of this, so we will have a set of alpha, alpha square, alpha 4, alpha cube, alpha 5, alpha 6, all the roots in one set, right? In one set we will have all the roots, this 3 and this 3, when we are doing the LCM between g1x and g2x. Okay, So that's why, however, it could be more appropriate. So however, it could be more appropriate to take the lowest common multiple, that is LCM, of these two polynomials in order to avoid multiple roots. Multiple roots means redundant roots. Okay, so that's why we can take LCM, which will only add redundancy without improving the error correcting capability of the node code. Okay, so when so the minimum multiple, okay, minimum common multiple, when we are doing ultimately the LCM of between G1x and G2x, so we will have alpha squared. So we will have alpha square, alpha cube, alpha 4, alpha 5, alpha 6, all the roots in one set, so that alpha 5, alpha 6 are also added automatically. Okay, so we need, so for calculating two error in the received code bit, we needed only one extra root to form the fourth equation, right? But by doing LCM between G1x and G2x, now we will have all the possible roots. Okay, then the resulting generator polynomials is of the form, what will be the form of the resulting generator polynomials? So this, that means G4x equals to, because G1x was what? G1x was G1x alpha, G2x was alpha square, G3x was alpha to the power 4, but we have now the G4x. So this is the fourth equation, x to the power 6, 5, 4, 3, 2, 1, and x to the power 0. Okay, so which is, as has been seen in the chapter 3. So this is a thing that this is in agreement with the fact that in this case there is a system of 6 equation when the error is 3. So I have told you that when the error is 3, error bit is 3, error bit is m, then we need 2m number of equations. So when the error bit is 3, then we need 6 number of equations. So this is written here. So this is the agreement in the fact that in this case, when t equals to 3, system of 6 equation that allows us to determine the position and the values of up to 3 error in a given code word. Okay, so that is the basically, that is the purpose of considering the LCM of G1x and G2x. That means considering the another possible polynomial equation of GF8. Okay, and I think we have understood that why we are doing this G1, why we're doing this LCM, because we need another equation, another root actually. Okay, so that's why we are doing the LCM between G1x and G2x. So we will have all the roots, all the possible roots. That means when we are doing LCM of this two, so we have a set of all possible roots. That means alpha, alpha square, alpha to the power 4, alpha cube, alpha 6, alpha 5. Okay, so this will be sufficient roots. And when we are actually determining the error or detecting the error of 2 bit, or when the t equals to 2, then we have already